Welcome. My name is Daniel Thibault. In this session, my colleague Heracole and I will be talking about the ArcGIS REST API. More specifically, we will show you how you can work with the utility network through services. We will first be covering the ArcGIS server architecture before looking at the REST API of all the services that gravitate around the utility network. Finally, I will be showing you how to get access to the utility network information through feature service and how to perform a sample editing workflow using only the REST API.
Okay, we're going to spend a little bit of time talking about the general service architecture that we're working with in this context. Then also, we're going to take everyone through an overview of the REST API before Daniel takes us into more interesting lower level details and all the rest. So, in any event, it's important to try and ground yourself. Make sure you're grounded in terms of how the architecture is laid out. When the utility network was shipped, we built upon ArcGIS Enterprise and the map and feature service model to provide 4 new additional services to users. Now, what's interesting here is you can see them in this diagram where we have the Pro desktop client on the top communicating, talking with the geodatabase, going through the feature service workspace, which itself is responsible for the communication via JSON to the REST APIs inside ArcGIS Enterprise. The services themselves are sitting on top of the same geodatabase implementation, which then works through an enterprise workspace or SDE workspace to communicate to enterprise geodatabases on the back end. So the new services that we have, of course, are the utility network service, which deals with all the network topology, the network index, the tracing, subnetwork management, supporting our new named trace configurations capability, all those things that are related to the utility network directly. The network diagram service is responsible for essentially providing schematic or logical representations of the data, being able to build and manage your diagrams, work with templates, and actually configure the system to provide these logical views. The version management service is used by any of the dataset types and clients that are actually trying to exploit the branch versioning model through a services-based deployment. And it's only supported with branch versioning. It does not support traditional versioning through the version management service. Then we finally have the validation service, which is the mechanism on the back end that we support attribute validation rules, as well as batch calculation rules. Now, this is again just zooming into the picture before. But we're also noting file geodatabases, which is interesting. So if we look at it from the utility network perspective, the utility network can, of course, work with file geodatabases on the client side through sort of a client-server mechanism. And this is the pieces of the infrastructure that you would see. Okay? Now, if you are instead working with a different client, such as a web application or whatnot, a custom web app, you can use our JavaScript SDK. And the JavaScript SDK itself is communicating through JSON and hitting the same REST APIs that you would through ArcGIS Pro. Okay. Finally, you can consider things from a runtime or mobile perspective, where the mobile clients using the Java SDK, the Qt SDK, iOS, .NET, Android, whatnot, are they themselves going through the runtime geodatabase implementation, which in a connected environment is then going through JSON to hit the REST APIs on the ArcGIS backend. So that's giving you a little bit of an overview of the overall architecture. Another kind of marketing type picture where you have enterprise at the center of everything. And the service-based architecture can support the desktop, the Pro desktop. It can support mobile devices as well as web apps. So that's one of the beauties of having an enterprise-based architecture, is being able to support all these different client types and types of applications. So, talking a little bit more, let's go through a little bit of an overview of the REST API. With the 10.9 release, you'll see that the REST API is growing quite a bit for the utility network service. Okay, we see some new bits and pieces on here. Let's start going through those. First, we see 4 new family resources. These are termed family resources. You can almost think of them as being sort of namespaces for different types of operations that are being supported by the utility network service. We have things handling the associations, our association model. You have locations, you have trace configurations for supporting a name trace configuration capabilities, all the rest. Diagnostics you see in this diagram as a new family resource with the utility network service at 10.9, although when we ship 10.9, it's essentially going to be it's a reserved family. We are not supporting any behavior, and it will essentially no op when you try and call the operations verifier and repair on it. We're hoping to have those supported shortly. So with the family resources, rather than just adding them on at the root level to the utility network service as we've done previously, we would, as you can see, we'd have to add 9 new operations to the utility network service. We've chosen to instead adopt a little bit more elegant family resource organizational mechanism. Okay. Now, one of the things whenever we're introducing or adding capabilities onto the utility network service with any release, it's important to look at the service capabilities that are being returned when you query the root resource. So at 10.9, you can see the new service capabilities that are being exposed with the 10.9 release. And then some other capabilities that were exposed with the 10.8.1 release that were always returning false, such as support query associations, support validation types, support validation sets. They are now supported at 10.9, so those capabilities will return true values at 10.9 when you're querying the service capabilities. Okay. Named trace configurations. Named trace configurations are an important new abstraction that's being supported across the platform at 10.9 and ArcGIS Pro 2.8, where you can essentially define a trace configuration and you can give it a name and it can be persisted and stored and you can manage it. This makes it much easier in a large enterprise deployment to have some of the people being able to develop these sophisticated trace configurations without and have other users be able to take advantage of them and use them. This is, again, a new service capability, and we have created this family resource called Trace Configuration, which supports 4 methods: the ability to create a trace configuration, alter a trace configuration, query them, as well as delete them. Now, when you're creating a trace configuration, no big surprises here. It's what you would expect. The trace configuration will support the following properties, such as it will have a name. It can have an optional description. It will have the trace type, the type of the trace. It will have the trace configuration itself. This is what you would typically be providing to the trace operation inside the utility network service, as well as you specify the result types, and you can also specify some optional tags for these named trace configurations. When you're doing a trace operation, if you want to utilize one of these named trace configurations, when you're performing a trace, there is a new parameter that is being supported on the trace operation called Trace Configuration Global ID. And here you would specify the named trace configuration using its global ID. Okay. Another new capability that we're exposing through services that we had with the revised association model is an associations family resource. And this is basically a very nice and easy way to be able to either query associations or traverse associations. By traversing associations, think about that in the context of hierarchies of associations. Say the telco domain, where we have a fiber strand that's contained within a sheath, which is contained within a cable, which is contained within a duct, which is contained within a duct bank. So you can create these large containment hierarchies if you want to. And this provides you with a mechanism to allow you to traverse them effectively. Okay. Again, at the root resource, where there are two service capabilities that are being exposed. First, supports associations and supports query associations. On the query operation on the associations family, that's the basic simple way to get access to the association table. Now, with this, you can see some of the parameters that it will take is, in addition to the version and moment, you specify the types of associations that you want to have returned, whether they are things like attachment, containment, junction-junction connectivity, junction edge from connectivity, the rest. You can also specify the elements or the features that you want to have you query the associations on. Okay, and you can also return logically deleted associations. Remember, with the revised association model, if you delete a feature that has an association or you delete the association itself, it is logically deleted until a subsequent validate network topology is able to remove it from the network topology. That's why we have the logical deletion model. And here you can ask the system to return things that are logically deleted. Traversing associations, we mentioned that earlier, where you're able to traverse up hierarchies of these associations, these containment hierarchies and whatnot, to retrieve the collection of features and non-spatial objects that are found in these association trees. You can search in different directions, either ascending or descending. You can specify a maximal traversal depth. You can also specify the type of traversals that you want to have, be it dirty area expansion, returning the top containers, the modified objects. All that is detailed. All the definitions for these are detailed in the online help doc. The locations family resource basically is providing you with a mechanism to allow you to understand or obtain the spatial location of either features, associations, or non-spatial objects. If you're asking for the locations, querying the locations of non-spatial objects, it will give you a synthesized geometry representing the features upon which those non-spatial objects are contained within or connected to the spatial things that are containing them, the derived geometry. The same thing with associations. It allows you to visualize the association through this API. No big surprises there. If you look at all the parameters on query associations, it's pretty much everything that you would expect. I don't think there's anything there that's different or unexpected. You have your collection of objects that you're asking for to query the locations from. You can specify whether you want to have the attachment, connectivity, or containment associations, whether you want the locations themselves, the derived locations returned, or whether you just want to have the associations themselves returned. Any event, pretty basic API, and it is exposed as part of the new 10.9 Utility Network service. Another interesting capability that's being exposed at 10.9 is on the existing validate network topology operation. What we're doing is exposing new ways to perform validation. By that meaning, you can tell the system to validate network topology and rebuild, restitch the underlying network topology. Do not try to use the existing elements inside the network topology, but to restitch it from first principles by honoring the dirty areas. That's the rebuild type. If you say specify force rebuild as a validation type, That will do the same thing where it will remove all the underlying network elements inside the network topology, create new ones, and it will not honor the dirty areas. It will do this operation on anything that you specify, either everything contained within an area or contained within the validation set. A validation set is essentially a collection of, of features, either spatial or non-spatial, that you want to have rebuilt, okay? So that's what the validation set is for, and it can be used in conjunction with the validation type. Validation type normal is by default. That's how the system works. Okay, other things that we do have inside the system, of course, we have the network diagram system. You can see the representation of it here. Finally, other things, when you're using these services, you'll frequently utilize the version management server as well as the validation server. So we've taken you on a very quick tour of the utility network service and what we have done to enhance it in the 10.9 timeframe. Now what we're going to do is Daniel's going to take us through a deeper level exploration of these new capabilities.
Let's look at how we can get detailed information about a utility network from a feature service. The feature service provides access to feature data. There are essentially three levels where you can get more information about this data and its schema. As shown here, the top level is the feature service root. It will inform you about the service's content, such as the layers and the tables. The second level is the layer or table itself. In this case, we're precisely looking for the utility network layer. This layer will give basic information about the utility network and its participating layers and tables. Finally, there is the layer's data element, which I will define later on. This is where you will find all the detailed information about the utility network. The feature service root JSON contains many properties. It also contains a list of layers and tables that make the service. In order to know if the feature service points to a utility network, simply look for a layer of type utility network layer. Once you open the utility network layer, you will get information such as the network extent and the presence of any sublayers. Most importantly, you will find a collection of system table IDs. Those are dirty areas, associations, subnetworks, diagrams, and so on. With these IDs, you will be able to query those tables as you would for any other table or layer in the feature service. The data element can be defined as the schema or dataset definition. It holds all the properties necessary to understand and work with a utility network in this case. From a feature service, the way to access the data element is through the query data element operation. This operation takes in an array of layer IDs. For instance, to get information about the utility network, simply pass in the utility network layer ID in that array. Query data element returns a rather long and complex JSON object, which I'm showing the eye-level structure here. Since the operation can be performed on many layers, layer data elements is an array that contains information about a single layer in each of its composing element. Those layers are identified by their layer ID, and then you find the bulk of the information that really interests us, which is the data element itself. Now, for a utility network, the data element will give you four main informations. The first one being the collection of domain networks that are contained within that utility network. The second one will be all the network attributes that are defined in your network. Then you will also find all the terminal configurations, and finally, the network categories. Now let's look at this more in detail. The first level of information that you can get from the data element are the general network properties. Those inform you about how this utility network was published, but also give you inherent information about its schema. So if you look in the JSON response example that I'm showing here, you can see that you get, the name of the utility network, when it was created, the version of that schema, so the utility network schema itself, who published it, and what pro version was used to actually publish the utility network service. You will also get the service territory feature layer ID, since technically that layer doesn't participate in the utility network, but it is valuable to know this information. Otherwise, we will go in more details about all the remaining properties, which are the domain networks, network attributes, terminal configurations, and category. When we think about the structure of a utility network, we immediately think about domain networks. They are very important because they tell you what are the different domains that are contained within that utility network. You will also find, on top of name and their ID, you will find information about whether this domain is a structure network, and also, most importantly, the tier definition and all the junction and edge sources that are defined within that domain. Speaking of network sources, as you may already know, the internal network index actually works with source IDs. So when, for instance, you get back a trace result, you will see that you get, global IDs, but you also get that source ID number. So it is very important to understand that you can actually map that source ID back to a layer, so you can then query the appropriate layer to get all the data. So the way to do that is very easy. So under each domain network, you will find a list of junction and edge sources. Within those, you will first get their source ID number, as showing here. Immediately after that, you will get the corresponding layer ID, which you can then use to map back to that service. You have to be careful that this mapping is dynamic, which means that it all depends on the order of the layers when you created your map and then published the service. So this mapping is only good for that specific service. So this is where you would need the data element to get that information at runtime to be able to do the mapping from one to another. The network attributes can also be found in the data element. They have their own section which contains all the properties for each of those attributes. Next, let's talk about the terminal configurations. Now, I'm showing a bit more information here because I want to let you know how you can actually map from an asset type terminal configuration ID to the actual definition of that terminal configuration. So on the left, I'm actually showing the hierarchy under a specific domain network, then under a junction or edge source, and you get to the actual asset type that you're interested in. And within that asset type, you will find a property called terminal configuration ID. Um, so in order to get more information about that configuration and get the list of terminals that are applicable to that asset, you have to go down to the terminal configurations object right under data element. And this terminal configurations object will contain each of the configuration which will be identified by the terminal configuration ID. In there, you will find a list of all the terminals and also valid paths if the case is. Lastly, the data element also contains the list of network categories that are available in this network. This is a very simple object that only contains the various names of the categories that are then referenced in each domain network. If you have to write an application, such as a web app for instance, you will be happy to know that with ArcGIS Enterprise, you can interact and edit utility network data through services using the REST API. Here, I'm giving an overview of the steps that we will follow together in this workflow. Also, I'm showing the primary service that is involved in each of those steps. So the first step that we will do is actually creating a version and starting our edit session. Then we will edit the data, validate our changes, rebuild our network index, create a network diagram, and finally reconcile and post our changes. In the first step, we will use the version management service to create our version. So for this, we will use the create operation and provide a valid version name. The version management service will respond to us with a version info object, which will mainly contain the version name and the version GUID that we will then use when we want to actually get to that version. So next, on the client side, you will need to generate your own session ID. So this is a GUID that you will need to pass around to tell the version management service which session you're currently working in. So once you've generated that session ID, you will go to your version endpoint, which is under versions, version GUID, and you will start reading that new version that you just created. So to start reading, you will pass in your generated session ID and you should get success back. So anytime in those diagrams that I'm not explicitly showing a response is because it's mainly just a success true false that you're getting back. So once you're starting your read session, you want to also start an edit session on top of that because you basically want to edit data. So yet again, you'll go to versions, your version GUID, start editing, pass the session ID, and this should return true. So now let's go to the actual editing part. For this, we will use the feature service to actually edit that data. The first thing that I'm showing here is to reserve some object IDs that you will then need to create your data. This is done by going to your layer ID endpoint and calling the reserve object IDs operation, um, where you will need to pass in the new version name that you just created and the session ID uh, that you've used to start that edit session. And the last parameter is the count, so the number of object IDs that you need to reserve. You call this method just to make sure that you're reserving an amount of object IDs that won't be used by anyone else, so there won't be collision when you try to edit. Once you've called this operation, you should get back essentially two things. You will get back the first object ID. Let's say we were at ID 9, so the next one logically should be 10, so that would be the first object ID that you get back. And then is the allocated count, so how many were actually given back to you. With those two information, you will be able to get all the IDs because what Enterprise is giving you is a sequence. So with these object IDs, you're able to actually edit the data. For this, you will call the apply edits operation. So note here that there are two apply edits operation on a feature service. There is one at the root of the service, and this is the one that I'm showing here. And then there's one at the layer level. So you would go layer ID, apply edits. There's no difference in using one or the other. The only advantage of using the one from the root is that you can edit data from multiple layers or tables in the same operation. So yet again, when you call apply edits, you have to provide the version name, your session ID, and then a collection of either adds, updates, and deletes. Before I move on to the validation step, you will notice, and I didn't say that before, but you will notice that I'm not showing any JSON payload or response in my example. The reason is that you can use the API reference documentation to guide you with the format and some examples of the various operations. For a clarity reason, I didn't want to put more information on those slides and wanted to keep the focus on the actual workflow and the sequence of operations rather than the payloads themselves. So for step 3, validate changes. When you're working with a utility network, you have some rules that may have been defined on that network, right? So telling you that you can or cannot do certain things, right? For example, I cannot put a pole, let's say, inside a substation, right? That wouldn't make sense. So that could be a very simple example of a rule. What you will do is use the validation service once you've edited your data to evaluate the changes that you've made. For this, you will use the evaluate operation and you will yet again pass in the version, the session ID, and the area which you want to validate and the type of evaluation that you want to do on that area. So once you do that, you may get back some errors. If this is the case, you will need to process those errors. So you will get a list of error layer IDs and you will be able to query them as you query any standard layer. And you will get a set of features and you should get their corresponding error. And from there, you should be able to fix those errors by yet again going back to the feature service and calling apply edits and rectifying the situation. Once you're done editing your data, the most important thing when you're dealing with a utility network is you need to make sure that your network index is up to date and basically clean. So for this, on the utility network service itself, there is an operation called validate network topology, which takes in the version, the session ID, and also a validate area that you want to use to rebuild that network index in this spot if required. Usually or normally what you want is that validation to return success. If it's not the case, it will give you an error telling you what's wrong within this area. And you can actually then fix those errors and try again, basically. Another step that you could do, which is optional once you've validated your topology, is you may want to run a trace just to ensure that the changes that you've made to your network are actually what you wanted them to be. You can use the trace operation off of the utility network service and you pass in the version, session ID, and there's more parameters here, right? You need to pass in a trace configuration, the trace type, your starting locations, so on, and you will get back a trace results from that trace. Once you've done that, you need to stop your edit session and save the changes. That is very important. So you will go back to the version management service and you will go to your version endpoint and you will call stop editing with your session ID. And very importantly, the second parameter, save edits, you must set to true. Otherwise, if you don't, then all the changes that you've made so far will be lost. Once you've stopped editing, you can then call update subnetwork, and that will go and basically update all the attributes for your subnetwork and make sure that those are clean. So you will yet again use the utility network service to do that. You will call the update subnetwork operation with your version and your session ID. Optionally, you can choose to create a network diagram. For this, you will use the network diagram service and you will first look for what templates are available to you. So basically use the templates resource, which will give you back the list of templates. You will again start an editing session, passing the same session ID that you've generated at first. And then you're ready to create your diagram. So what you will use for those features that you will pass in to create the diagram would be normally the ones that you got back from that trace that you did earlier. So this is why trace might be important. So if you changed a whole section of the network and this is what you want to create a diagram off of, then you will use those features and send them to the network diagram service using the create diagram from features operation. Still same recipe, you pass in the version, the session ID, which template you want to use, and the list of features that you want to basically create a diagram for. So this will return to you a diagram info object, which basically contains all the information about the diagram that you've created. So with that diagram ID that you got, the diagram GUID, you can then go to the endpoint, so diagram slash diagram GUID, and you can get the layer definitions. So all the different layers from that diagram will be returned. So those layers are dynamic in the sense that they're created on the fly. So they weren't part of the service before, but as you created that diagram, um, the diagram service went in and generated those dynamic or temporary layers for you to consume. So you can go ahead and consume each of those layers individually by going to their dynamic layer ID. So diagram slash diagram GUID, dynamic layer ID, and then you would query as you would query any other layer. And this will basically give you the feature set for that specific diagram layer. The last step, once you've edited your data, you validated your network, you created your diagram. So the only remaining thing is if you're happy with your changes and you want everybody to actually work with those changes or see those changes, you will need to take the data from your version that you created and you want to literally post it to the default version so that it will be available to others. For this, we will again use the version management service and we will go to our version, so version GUID, and use the reconcile operation first so that we can get any change that happened between the moment we created our version and now, so that if there's any changes that were made in default by other people, we will get those changes and we will see what can happen there. So you use reconcile, you pass in your session ID, and importantly, in this case, I'm subdividing the operations a bit more, so I don't want to post immediately, even if I can. So just for this workflow, I will say with post equals false, and this is what I'm showing here. So you would reconcile your changes, and if there are any conflicts, they will be returned. And you will need to basically resolve every of those conflicts. So a conflict can be very simple, right? It could be on two objects that somebody has changed the same attribute than you in another version and posted before you. So if I change attribute A and somebody else changed attribute A, I've put one, they've put two, there is a conflict. We need to resolve it by saying, well, which value is the right one, basically. And conflicts can happen at the object level, the attribute level, and you need to fix them. So bottom line is you cannot post your data if there are conflicts. So you would go ahead and resolve those conflicts. So basically reviewing all of them and making the necessary changes. Yet again, using apply edits with updates, you would go and update the data accordingly. And once you're happy with those changes, you will be ready to post your version. So you will go back to that version and call the post operation with the same session ID. If this succeeds, then you're good to go. You can say, I'm going to stop my edit. Again, I'm saving, but I mean, at this point, I've posted, so it doesn't really matter. But I mean, in this case, I'm showing that I'm saving those edits. And once I'm done with the version, um, I can go ahead and delete it. So if I don't need to keep that version anymore because everything was posted to default, I don't want to make any more changes. The best practice is to simply delete that version by going to the versions resource and calling the delete operation and providing the version name and the session ID that you were using. So this basically gives you a good idea of well, somewhat simple workflow, right? Or I would say more a complete workflow that you can do solely by using services and the REST API. So to conclude, in this presentation, we actually saw that ArcGIS is a service-based architecture that gives you the ability to do pretty much everything solely using the REST API. That REST API is very rich, and this is what I showed you with the workflow that you're able to build, full working client applications solely based on it, and those applications will follow the same patterns as Esri software, right? So think about ArcGIS Pro. ArcGIS Pro, when you're working with enterprise, does the same thing. It works solely using services to accomplish all the workflows that you want to accomplish within Pro. So we've seen that the feature service is basically useful to get the network properties. Version management service, you use it to create and manage your versions. The utility network service is there to execute analysis and manage your network itself. Network diagram to create and manage all your diagrams. And lastly, the validation service that you use to check your data and ensure that it meets the requirements. Lastly, I invite you to visit the ArcGIS REST API services reference with the provided URL that I'm showing here to get more information about all the different services and more importantly their resources, operations, the different JSON payloads that you need to provide the parameters, the responses, what they look like with complete examples. And more specifically, within that API reference, there is a section on the utility network services that gives you a very good overview of the various services involved in the utility network. And also, we've added a new appendix section which highlights some of the things that I've talked in this session with regards to the data element, for instance, and ways to get properties to better interact with your utility network. I hope this was valuable, and I wish you an excellent day. Thank you.